Large language models, or LLMs, have broken the traditional pull request review model. A pull request is a collaborative process where developers submit code changes for human inspection before those changes are merged into a project's main branch. Human reviewers physically cannot keep up with the sheer volume of code generated by these agents. This chart shows the widening gap in engineering velocity. As AI-generated code continues its exponential climb, human review capacity remains a flat horizontal line. The danger is that standard linters, automated tools that scan code for syntax errors, only check for basic formatting. They allow an AI to generate poor architecture that still receives a passing grade. Relying on developer trust and basic linting in an AI-heavy workflow guarantees architectural rot at scale. We need a DevSecOps approach that mathematically enforces architecture. DevSecOps is a methodology that integrates security and compliance checks directly into every stage of the software development lifecycle. The Keras stack provides this by physically blocking structural drift in the developer's local environment and at the CI/CD level. CI/CD, or Continuous Integration and Continuous Deployment, is the automated pipeline that builds, tests, and deploys code. The stack utilizes AST-aware bundling, tiered pre-flight audits, and hard gates to separate an AI agent from the core codebase. This system treats architectural rules as immutable laws, rather than advisory guidelines. To survive the speed of AI, you have to stop auditing the code and start auditing the constraints. Feeding raw, bloated files into an AI wastes context window tokens on comments and boilerplate. A context window is the specific amount of data an AI can process in a single session. The solution is an abstract syntax tree preprocessor, a tree-like representation of a code's logical structure. It strips code down to its pure semantic logic. The generate semantic bundle script then packages this into a hyper-dense text file, ensuring the AI receives only essential data. Modern coding tools like Cursor or Windsurf handle some of this indexing automatically, but they do not bypass the need for strict routing. Denser semantic input significantly reduces the opportunity for the AI agent to hallucinate or drift outside of the established architecture. When AI produces code, we must determine which files actually require a human architect's intervention. The pipeline calculates cyclomatic complexity at a calculation node. Scores under 5 take the fast path for auto-merging. Scores between 5 and 20 trigger the standard path for AI verification. Anything over 20 hits the stop and think path, locking the gate for human review. Certain high-risk actions, like modifying database schemas or authentication logic, will force a manual audit regardless of the complexity score. This routing ensures that critical infrastructure stays protected, while low-risk features deploy at maximum speed. In front-end development, AI tools tend to generate generic layouts and boilerplate styling, often called AI slop. Design guards act as a local filter. If an AI attempts to inject a raw hex color code, the system rejects the commit immediately. The protocol enforces an exponential typography scale, a strict 1.5 ratio, preventing the AI from creating linear, inconsistent text. These constraints are validated in the developer's editor before the code ever leaves their machine. Enforcing aesthetics as hard data prevents the AI from diluting a brand's visual architecture over thousands of microcommits. The most critical hardgate tests for what we call the horror path. This is a failure state scenario where external APIs or databases become unreachable. AI-generated code is blocked from merging unless it includes active recovery mechanisms, like circuit breakers, and exponential backoff, progressively increasing the wait time between retries after a failure. This requires mandatory state restoration. Before a network call, user data must be persisted to local storage, like IndexedDB. If the connection returns a 500 error, the system pulls the pre-submission state back from storage, allowing the user to seamlessly recover. Traditional testing only checks the happy path or success state. This makes AI-generated code dangerously vulnerable to edge case failures. Mandatory horror path compliance turns system resilience into a mathematically verified prerequisite for shipping code. At scale, this looks like an autonomous DevSecOps pipeline, a stream of data moving through high-speed checkpoint gates. The Keras stack handles every step: stripping code, scoring complexity, routing audits, and verifying the horror path. This changes the role of the senior engineer. You move from a manual code reviewer to a system governor, defining the laws the pipeline enforces. Scaling AI development requires more than just better prompting. It requires building an impenetrable perimeter around the codebase. There is a final layer to this: the legal ownership of AI-assisted code. Because this system harvests metadata and complexity scores during every build, it provides proof of human intent and conception. This automated logging aligns with the USPTO 2026 revised guidance, establishing a forensic chain of title for human inventorship. Hard gates protect the technical stability of your software while simultaneously securing the company's intellectual property. Stop trusting developers and AI agents to remember the rules. Encode your architecture into the pipeline and let the mathematics enforce the boundary.